So, ladies and gentlemen, good morning. So, welcome to the second day of a high-level conference. So, welcome also those that are connected online. I hope that you can hear us fine. So, yesterday we heard several interesting speeches that are showing that there is a lot of expectations on how this market will evolve in the next years. So today we will try to focus on where we are, what we need to develop in order to really have some drone operation, and also if there is any feedback that we will receive from you in order to improve our activities, where we need to tweak to the regulations. So here is a new sector where we are all learning all together. So it will be important to have this kind of exchange of information. So today we are discussing here mostly the operation in the specific category that can be operated in the urban environment. So we will focus more on those that in the specific category will be in the higher risk. We will have 4 panelists, so I will introduce them in a few seconds, and where they will set the scene, providing some presentations. And after we are going to answer to questions, so you can pose your question on Slido using the code 472991. For those that are connected, please don't use the chat on Zoom because we are not able to monitor it. So use the Slido part. So before starting, so let me first introduce who are our 4 speakers. So we will start with Jeremie. He's the continuing airworthiness senior expert. So before joining EASA, he was working on Airbus on maintenance program development. Since 2008, he has been leading in EASA rulemaking task, introducing safety management system in maintenance and continuing airworthiness management organization. He's now the leader of the working group in charge of developing the future regulatory framework for the continuing airworthiness of certified drones operating in the specific category in higher risk, SL5, SL6, and certified category. So then our second guest is Leonardo CAPACCI. He's an EASA air operation expert. So before joining EASA, he spent more than 15 years in different positions in aviation companies involved in commercial air operators, as well as airplane and rotorcraft manufacturers. In March 2016, Leonardo joined EASA as rulemaking officer for initial airworthiness, and since March of last year, he became responsible for the operational aspect of the drone regulation and for the standardization inspection of the National Aviation Authority for the application of the drone regulation. Then we will have also another guest providing the information from the operators. Is Geert VANHANDENDHOVE. So he's Helicus flight operation manager. So before co-founding Helicus, Geert built a strong career in medical IT management positions. He's the source of company and flight procedures documentation and training material for complex multi-crew BVLOS medical UAS operation in populated environment. And as member of the board of Royal Antwerp Aviation Club, Geert is the representative of its declared training organization and is ground instructor for private pilots. Then last but not least will be also the important part on the development of standards, and we have Abinaya KANNAN, that is the EUROCAE technical program manager. So prior to entering EUROCAE, she worked at Air Labs Austria on a service contract to research and elaborate stakeholder process and contact points in each federal province in Austria pertaining to regulation for drones. Abinaya joined EUROCAE in June 2021, and she's the technical program manager for several EUROCAE working groups, and also serves as secretary for the European UAS Standards Coordination Group, EUSCG. So, let's start with a discussion, and before going into the presentation, I just want to set a little bit the scene So to remind, what will focus today on the discussion. You know that in Europe we decide to have our operation-centric approach. So developing the three category: open, specific, and certified. The regulation 945 and 947 deals with the open and specific category. And today we are only focusing on the specific category. So the regulation was adopted in 2019 and became applicable starting from 31st December 2020, even if there is a transition period that, as you may know, has been now extended up to the 1st January 2024. So the full regulatory package will become applicable completely in beginning of 2024. So in the meantime, I think we are all aware of the different timelines, so the milestone that will become applicable little by little. So today we are focusing on the certified category, on the specific category. So mostly, on those operations can be done in the urban environment, so higher level, higher sale. While for the certified category, we are now developing a proposal we call the NPA, Notice of Proposed Amendment, that will be published by mid of this year. We are not covering on this panel. There will be other discussion that will come later today that you can then join in the other workshop. So if you want to have additional information, please visit our website. We have a page dedicated to drones, where you can find all the documentation that is needed, so the regulation, the acceptable means of compliance. We publish several explanations, and we are going to improve daily. So please check it, but you can also then subscribe in order to receive all the newsletter from us. You can also find the videos, FAQ, and if you have any questions, you can address to our mail address, that is drones@easa.europa.eu. Okay, so let's start with the first. The first presenter is Leonardo. Please.
Thank you. Thank you, Lino. Good morning, everybody. I would like to start with a slide that you can, there is no surprise in this. The regulation, the EU drone regulation contains three categories of operations for drones. And today we will focus on the specific category. In this slide I want to tell you that the specific category can accommodate a vast number of different kinds of operations, as de facto is only limited on the fact that in the specific category we cannot transport passengers, dangerous goods, and we cannot overfly assembly of people when the drone is bigger than 3 meters. So you can imagine the number of operations that you can conduct within this category. And of course, the risk, the intrinsic risk of each of these operations is different. Then, thanks to Jörg that made this nice slide, we want to tell you that regardless the kind of operation that you are conducting, the goal of the regulation is to ensure that the target level of safety remains the same. So the safety for the people on ground and for the manned aviation should not be impacted by the kind of operation. How this is achieved? This is achieved by a different level of mitigation that is implemented in the different categories. For the open categories, for instance, we have a lot of operational limitations that reduces the risks for the people on ground. While for the specific category, we have been forced, according to the SORA methodology, to split the specific category into sales. We have 6 sales, and for each of these sales, we have a different requirement at operator level, at design of the drone level, and on the training of the pilot level. And of course, the operational limitations are somehow reduced as soon as you have a higher level of assurance and robustness of these in these fields. Then the overall idea for the specific category is that the operator will buy a drone, then will register as an operator, will carry out a risk assessment according to the regulation, and then will receive an authorization from the competent authority. After that, he can fly. Now, for the risk assessment, we have within the EU drone regulation, we have endorsed a methodology called SORA that was developed by JARUS, and the EASA cooperated in this development, is still cooperating with JARUS. And this is, so the first way to operate is to implement the SORA methodology that is contained as an AMC to the drone regulation. Then we'll apply for an authorization, we'll receive the operational authorization from the authority, and then can start operating. This is the first route, the first possibility, and of course it's always valid. But as a strategy, EASA is trying to reduce the burden for the operators in order to obtain an operational authorization. And one means to reduce this burden is to publish what we call predefined risk assessment. Again, is material developed by JARUS. And the predefined risk assessment is the fact that the implementation of the SORA methodology taking into account some assumptions. So each PDRA is valid only for certain kind of operations. So either BVLOS or VLOS with a certain level, the certain height, and so on. So today we have published 5 PDRAs, but we are committed to publish as much as possible in order to extend the possibility to use this route instead of having to implement the SORA methodology from the beginning. Another possibility will be to fly according to a standard scenario. This possibility relies on the fact that the drone is marked with a CE marking, C5 or C6. Today there are no drones with this marking, and therefore this possibility is something which will become applicable only in 2024. But in this way, as soon as this will be possible, the operator will have only to provide the declaration to the authority, and this will speed up the approval process for sure. The last possibility in order to operate in the specific category is to obtain the privilege of LUC. This is something that we expect to be achieved by operators with a certain experience and with a safety management system in place. But the main benefit of this privilege will be that the operations can be approved by the organization without having to apply for an operational approval from the authority. So this for sure will simplify the operations, but it has on the other side the need to keep the privilege alive, and so to have the organization able to discharge the commitment behind the privilege. So why PDRA is helping? De facto, it's helping because it allows you to skip all the steps of, not all the steps, but the majority of the steps of the SORA. So the idea is that as soon as you want to make an operation, you can check whether the concept of your operation can fall within one of the existing PDRAs. And if this is the case, instead of implementing all the SORA process, you can use the outcome of the PDRA and go to the authority with this outcome, which is basically a checklist, and together with the other documentation, other documents that are needed in order to get an approval. So this is where the PDRA will simplify the approval process. Now, as I said in the first slide, in the second slide, the level of intrinsic risk is different in the specific category. You can have operations which have higher intrinsic risks, and these risks needs to be somehow mitigated by different kind of requirement, which are at UAS level, at organizational level, or at training of the pilot level. So in this slide, what I want to show is simply that depending on the sale of your operation, you will have to comply with different level of requirement. And of course, the effort which is required in order to comply with the requirement is increasing as soon as you increase your sale. Jeremie will go to some details of the requirement for the organizations when the sale is increasing. Then here is the list of the published PDRA. You can find this in the material published by the agency. Today we have only 5, but the idea, as I said, is to increase this list as much as possible. And we are currently working together with JARUS on other PDRAs, indeed even more than 4, but the idea is that we would like to trigger also your requests. So if you have any specific need, you can approach us, telling us which would be your concept of operation, and then we can see whether we can accommodate this with a new PDRA or with an adjustment of an existing PDRA. Those which are in the pipeline are these. I think the first one, which is the PDRA 05, will become available maybe end of this year or beginning of next year. One is very welcome or very needed from the industry is the swarming one, because we receive regularly requests regarding the swarming operation. But again, if you have any proposal to have a new PDRAs, please approach us. This is one of the reasons of this slide. Then, the SORA methodology is published by JARUS and endorsed by the agency as an AMC. It proved already to be effective and to allow operations in a safe way. But the idea is that we want to improve and continue to have a better the methodology. We want to try to keep it alive and to have it adapted to the requirements. So we are working together with JARUS in order to have a new release of the Annex A of the SORA. The Annex A is the document that describes the technical content of the operational manual. This operational manual is something that is needed in the specific category. Of course, the contents and the dimension of this document depends on the sale. For a low sale, we don't expect a big document, but for higher sales, we expect something which is more comprehensive. And the content of this is described on this annex. So we have worked together with JARUS in order to improve the existing Annex A, and we have this Annex A 2.0, which is currently under external consultation by JARUS. This external consultation is recognized by EASA as a public consultation, so you are invited to comment, to read this document, to comment, and you have time till 7th of April. So not too much time, but if you have this opportunity, please go, and you have the link here, but you can also Google and you will find it. The idea is that when this annex will be mature enough, we will endorse it and we will publish. And in this way, we will also solve some inconsistencies that are currently present in our MC material, because we have two MC dealing with the same subject and they are not fully aligned. We are also working together with JARUS on a new amendment, a new version of the SORA. In this case, so this is the SORA main body. So SORA Annex A is just the operations manual. The main body is really the full methodology. And in this case, what we want to do, we want to improve the clarity. This is an important element because the document is quite long and it needs to be understood in the proper way. But not only this, we are also introducing the possibility to perform functional test-based method. We are introducing a quantitative ground risk assessment. The cybersecurity, which is missing today in the SORA published, will be introduced in the 2.5. And we will also have some clarifications on the SORA Step 9, because this is one of the element of the SORA which triggered the highest amount of concern, doubts, and difficulties in understanding. The timeline for the 2.5. Today, we are working. We are reviewing the comments that were submitted during an internal JARUS consultation. So this is just for organizations working within JARUS. But we plan to have an external JARUS consultation, and I would like to invite you to stay tuned and to read this document as soon as it will be published by JARUS for consultation, and to submit your comment in this phase. We as EASA are involved in the review of all the comments, so we will check what our stakeholder will say. And the idea is that the JARUS can publish this amendment by the end of this year, and we will endorse it probably beginning of the next year. This was my last slide.
Perfect. Thank you very much, Leonardo. So
Thank
we
you.
see that there is a lot of activity going on in EASA to simplify the risk assessment methodology, and also to provide some opportunity to the operator to avoid to use the methodology by defining this number of predefined risk assessment. I think that this is something that will be appreciated by the community. I just remind that, so for the question, please use Slido. So we will then answer to the question at the end. So now we have Jeremie, so we will provide some information regarding on the future requirements for the continuing airworthiness.
Thank you, Natale. Good morning, everyone. So let's talk about continuing airworthiness. Today we enter into a little bit more details. So just a quick reminder of what it is. So it's a process to keep basically any aircraft airworthy. And this domain of continuing airworthiness is composed by the continuing airworthiness management, all the configuration, compliance with AD, maintenance program. It is composed as well of the maintenance of the aircraft itself. It's also the maintenance of the components, the engines, and also the training qualification. In the traditional man aviation, we have included there the licensing of the mechanics as well. So this is a big domain, and this is what we are going to talk about today. So what do we have on man aviation? Just to keep the status, we have this regulation 1321/2014. It covers all kind of operation, including general aviation. And talking about general aviation, we have inside this regulation some dedicated annexes, this part light and part KO, which are there for to alleviate a little bit the burden of the general aviation. So probably you have heard they are since 2020 already, but it's important because for unmanned aircraft today, what do we have? We have this regulation 2019/947. We have also this SORA, and this is a living, as Leonardo said. And in the SORA, we have also some maintenance aspects. But we need to complement the continuing airworthiness picture for the unmanned. And we are working as a rule-making effort exactly on this. And why? And the why is on the next slide. Because, as we said, we have the specific category, we have the certified category. In the specific, we have the low, medium, and high risk. As you can see from the right side, the high risk of the specific or the certified category will require basically certification of the drone itself. So the drone will be certified on this category. And certified, and this is the other workshop next by, certified according to part 21. So we have to do something for the continuing of this, for the continuing airworthiness of this. So for the low and medium risk, we have this regulation. We have the SORA. In the SORA, we have the OSO number 3 for maintenance. So this is very good. But for the higher risk, certified category or certified drone in the specific, which is cell 5 and 6, basically, we need to develop something for continuing airworthiness. So, and the idea is quite simple. And actually it was mentioned by one of the panel yesterday. We want to reuse what has been developed for general aviation there. To start, as a starting basis, of course we will adapt to drone, but this will be our starting point. So what we want to do is to reuse for the high risk in the specific category, the part light and part KO, the general aviation annexes of the MAN, to develop this regulation. And in the certified category, it will come in a second step, but we will reuse more traditional annexes, CAMO 145, 66 as a basis, of course. So this is what we want to use, and we will go into step. First step, the certified drone in the specific category. So that's what this regulation could look like in the future. It's work in progress for sure. So we would have several annexes for the specific category, SAIL 5 and 6. We are speaking about certified drone. And we will have other annexes in the future for the certified category. So, and in the specific category, what we have in mind is to introduce 2 annexes. So we want to introduce this part-time light UAS and part-cow UAS. So just to give you a bit the idea that we have there. So the part-time light UAS will be the standard for the UAS. What do we expect the UAS to comply with? So what the UAS needs. So for example, maybe we need a pre-flight inspection, we need record of the continuing airworthiness, we need a maintenance program, we need to comply with AD, airworthiness review, we need to develop a system to release to service after maintenance, and so on. So this is the standard for the drone. And now the part cow would be the organization side. So who will ensure that these standards are complied with? So that would be the part cow UAS. It's an organization, it's an approved organization to apply the cow standard. So, and this annex will tell you what this organization needs. Not the drone, what the drone needs is part-time light, but what the organization needs is part cow UAS. And this organization needs facilities, personnel, manual, privileges. So this is what will be developed in this annex. And this organization would address not only the maintenance, but also the continuing airworthiness management of the drone. So we don't intend to introduce SMS as we didn't as well introduce it in the man aviation, but there will be at least some provision for cyber security, a kind of predetermined cyber risk analysis, basically. And as you can see, we are proposing an organization, a requirement, a standard for the drone, but we don't propose a licensing for the mechanics on this category. We believe that the organization will be able to qualify properly with a set of high-level requirements in the cow US to qualify the person. So, then, but if I buy a drone, what happened to me? So I buy a certified drone. So this drone has a TC. What is my first step to do? So we are really speaking about a certified drone by EASA. So the first thing is, and there is no discussion here, you have to register it. You have to register your certified drone. Then you have to see which of the operation you want to do. So if you intend to operate in the low and medium risk, then it's not a problem, as we said before. You have this regulation, 947, you have the SORA, OSO 3, you are, as an operator, you are responsible for the maintenance, for the continuing airworthiness management of your drone. But if you intend to operate in the high risk, SAIL 5 and 6, then this is where we want to amend this regulation 947 in this package, and then we will say, hey, you want to operate in the high risk, then you have to get a COA, you have to get a certificate of airworthiness. And this certificate of airworthiness has no validity limit because there is behind a review of the airworthiness every year or every 3 years, regular review. So, and then from that point on, then if you have a COA, then you would have to comply with this regulation. That would be the entry point to this new regulation, and you would have to have an approved organization to take care of your continuing airworthiness management of your US and of the maintenance of your drone. So, but what if I was operating in the low medium risk and I want to go in the high risk later on? So you want to change your operation. So first you check your design. Was my US certified for SAIL 5 and 6 or only certified for SAIL 3 and 4? So first thing is check that your US is capable of this high risk operation, and if not, then you have to apply for an STC or to major change to make it capable for high-risk operation. And then you have also, it's a bit like an import process. When you import an aircraft today from outside EU, you have to make a review of the airworthiness, and you would have, in this case, same. You come from a low, medium risk operation, you have to make an airworthiness review, and then you have to apply to a CFA, and then the regulation would then become applicable to you. So, what are the main challenges to develop this regulation? And one of the main challenges is a bit the new animal of this domain is a command unit, the remote pilot station, if you like. And we believe there is a challenge in which there are two kinds of command units, we think. So the first one is a kind of portable. Maybe it's very small, maybe it's a laptop, maybe it's in this suitcase, in this case here, but it's portable. And then maybe what we envision is if we are talking about certified drone, we would need then probably Form 1 for this command unit. And the Form 1, as you know, is something which comes from the production process or from a maintenance process. But if maybe we have another kind, which would be a fixed command unit, something which you have to install. Here, I took the picture of SpaceX. Okay, it's a bit futuristic, but this is the idea. Maybe you have to install. You receive a lot of components, and you have to install them to fit them together. And then, before you start operation, probably you have to release the installation. So you have to follow a certain set of instructions from the designer, and you have to release. And some of the components maybe will need a Form 1, some will need other kind of certificate. And maybe you have also to consider some environmental, the lighting, the air condition, temperature, things like this. So this would be maybe also defined by the design approval holder as a specification. And this release would be made by this organization. So, and in case of this command unit, we want to distinguish which elements will need a Form 1, which elements do not need a Form 1. And for this, we are following ICAO recommendation to work with layers in the command unit. The core layer, which is the most important element, and the other outer layer, let's say. So what we have in mind today is to apply this Form 1 and this very regulated process of production, of design, of maintenance on the core layer, the most important element. And maybe for the other layer, we can use other means like conformity certificate, and we can be a bit less regulated. And we would have also to have this specification around the temperature, lighting, and so on. So this is what we have in mind and what will be developed in the NPA that we are preparing. So just to conclude, we are it's work in progress. We want to issue for this drone certified in the specific. Want to issue this NPA before summer, maybe end of June or end of May, something like this, Giuseppe. And we are working, and there are some in the room today. We are working with you guys to this effort, and we want to propose. Okay, we understand we need to regulate, but we want also to keep the things simple and proportionate. So, and by the way, there will be also another regulation developed, but this time for the competent authority to monitor this organization or to monitor the airworthiness of the drones themselves. So that's it.
Thank you, Jeremie. So I understand that our aim is to try to find proportionate requirements to what is the real risk of the operation. And you may also be aware that at the 11:15 there will be a second panel that will focus more on the initial airworthiness. So I invite you then to follow us to that one. So now let's see what is the feedback from the field, from who instead is applying all this regulation. So Geert, please.
Thank you, Natale. So indeed, all this work that is hard work that is being done is not happening in a vacuum. It's required by somebody, and we are part of that somebody community, basically. From a Helicus perspective, I will explain to you what we do, why we do it, and how it links to the work that is being done by the different bodies that we are talking about, creating the legislations, the framework in which we need to operate as a higher risk operator. So basically, what we do as Helicus is driven from our roots are, you may have heard about it, in the medical environment. So we got our requirements from the medical community. Myself, I'm coming from a medical company background, as most of the members of our team, basically. And what is the challenge in the medical community? We have seen, and we are not the only ones providing medical transportation services by a drone, but this is driven by a need from the medical community. Costs in the medical world are increasing. Due to better medical, that's actually contradictory, better medical treatment, making that people are living longer, so need more treatment, etc., rising costs in the medical area. And the medical community wants to, and actually is forced by governments also, to reduce costs and maintain the same or higher quality medical services. So the medical community is looking at how can we achieve that, and that is achieved by centralization, which means that expensive components of the medical activities are being centralized. Medical labs, pharmacies, these kind of things are being centralized. That centralization brings an increase in the demand for transportation, also urgent transportation, which is typically, and we all know, not always possible by ground transportation, not always by a car, not always by a bike, because roads are saturated. The requests that we see from the medical community are, in many cases, are also on the spot, on demand, and there is not a taxi driver in front of the building of the hospital waiting for a medical sample to be urgently transported, nor is that bike there. What we can offer is actually a drone sitting there on the rooftop of a hospital to urgently transport medical sample or medical pharmacy component. It's on demand, and also on top of that, what is being done when transporting these components is monitoring the sample quality, temperature, humidity, vibrations, these kind of things. We've seen the involvement of the medical or the drone technology gradually enabling to fulfill that need. Now, the thing is, of course, we all know drones can fly, they are fast, but we need a very fast end-to-end process. So when we get a request in from a hospital, we need to be very fast between that request and actually taking off with a sample and bringing it to the other side. And we all know that in between, a lot of lengthy processes can be in place that are slowing down things. So how does it link to this higher risk? So typically, of course, we fly from one hospital location to another. So that means, by definition, BV loss, one. Secondly, most of those hospitals and medical facilities are situated in urban environments. So this means populated. So there you have already a driver for high-risk operations. And we are carrying cargo. I'm not even talking about potentially dangerous goods, because then we are even a certified arena. But let's just focus on the specific component here. And another thing is, so we are BV loss impopulated. So the higher risk, we potentially look at sales 5 and 6 from that perspective, and certification of machines, basically. And we have also seen that the medical community wants to drive down costs. So what we, as a from a user perspective, it's easy for me to ask, of course, is the challenge that all those people that are working on the framework that we are operating in is actually to ensure that the cost of the certification of the drones, and we have seen the different components which make, let's say, the complete service possible in high-risk environments, and the organization and the training of the personnel. So all these components need to be achievable in an efficient way. So that's actually our driver, which is driven by the demand from our clients. And also we have to, of course, be competitive to other mobility solutions. So to maintain that medical service level for the medical community, we need to be reliable, fast, and safe. And that is actually another driver, not only the fact that we have to operate in higher risk environments, but another driver for having more reliable machinery and processes. Because not only from an environment and regulatory perspective from the aviation side, we have a demand for reliable, fast and safe transportation, but also from the medical side. They also demand that we are safe. We cannot just lose, let's say, a medical transport, even if it's landing safely somewhere by a parachute that doesn't serve the medical community. So, explaining a little bit in increasing, let's say, grade of complexity, the different use cases from a medical perspective that we are working on, starting from the left with the, let's say, easiest one, which is about anatomic pathology, clinical biology, and pharmacy. So that's pharmaceutical treatments like for oncological, cancer treatment, for example. Those typically are components that are difficult to make, need to be made in a clean room and expensive equipment, and is also being centralized, but it needs to be administered to a patient within the hour, making it urgent to be transported between two facilities. We have, let's say, tissue samples also being cut from a patient during an operation, typically also in an oncological context, that also needs to be quickly analyzed to allow, during the operation, to have a positive or a negative feedback towards the surgeons, basically. So that's what we're currently working on. What makes it possible today, we are talking about fairly small volumes of cargo that need to be transported, small samples. They are urgent, so from, let's say, a benefit to the medical community, they are a very strong case. The next one, the second from the left, we're talking about blood supplies. Already that is a little bit added complexity. Because we're talking bigger volumes when we're talking about blood supply. The third one is the last mile for organ transport, which you can imagine is an additional complexity because of medical regulations that are in play, of course. And we're also talking about typically larger volumes. The fourth one is delivering a defibrillator, an AED, for example. The case is very strong because every minute that a person with a cardiac arrest is not getting treatment is actually a reduction in life survival chances by 10%. So that means after 10%, virtually no chances are left. So this is a very interesting one, but a very complex one, because when we're talking about delivering an AED, there are activities going on also by let's say, our colleagues. It's a complex one because you know the A, where you deport, but you don't know where you have to deliver, making the operation very complex, especially when you want to make it automated. And then the fourth one is really manned transport, or of either a doctor, an emergency doctor to an emergency location, or a patient to a hospital. And that's indeed further out. But these are all the different use cases that are in the pipeline, and depending on the case, in a further stage of maturity from our perspective. So this is the architecture, high level, as to how that looks like from an integration perspective, because basically what we do as Helicus is integrating all the different components that allow such a service. And basically this starts at a hospital side, taking in the order, translating that into a flight plan, a trajectory, submitting that to the UTM, the USSP, to get flight approvals back. And basically the requirement that we have to the USSP there is to get our feedback, our approval of our trajectory within the minute, because that's also what is being asked to us from the medical community, to be fast. Yeah, so that's actually the aim, the goal. And then we have that flight plan, uploading it to the drone, executing and having it arrive at the arriving location. In parallel, we have also the logistical process going on with the drone being charged and loaded with the cargo, and at the receiving end also the cargo being taken out. So basically, we also, Helicus, we don't build drones, but we have, looking at the topic of today, we have a long list of user requirements toward the drone community. And that means being able to operate in the conditions that I just talked about, which translate into the continued, the airworthiness and the continued airworthiness of the machinery, but also, let's say, other services, like towards USSPs, etc. So we are integrating all these different components. And so the clients, the drones are integrated, so multiple types of drones, and we've got those specs. From a software perspective, those drones need to be able to be integrated into our ecosystem, as well as from a hardware perspective, because what we are building, though, is a drone cargo port, which is actually a kind of a hangar, also a post office for those different drones, but is integrated closely with the hospital itself. And again, when people want to talk about that separately, I can continue talking about that quite for a long time, but I'll keep it at that for the moment. So, and also other, well, data sources, etc. Other things we're building, I talked about the preservation of the medical cargo packaging, the sensors that are inside that packaging, and etc. And we are also making that available basically to other operators, because we've developed all those good things that is also available to made available to other operators. So towards the topic of today, basically, again, repeating, the biggest medical demand for transportation is in urban areas. So that's a clear driver for us to really need that high-risk operations into in high-density, population density environments. Also, those environments are typically high-traffic congested. So also there is a driver for the demand towards, let's say, urban air mobility from our perspective. And also we have a demand, not only from a regulatory perspective on the aviation side, to not lose, obviously, a medical mission. As I mentioned, the type of cargo that we are transporting, you can imagine that those samples sometimes are unique and cannot be replaced, so we need to have them safely arrive at the destination. So also from that perspective, we need to have a reliable context from a hardware, organization, and training perspective. And so the current limitations, right now, we all know we have to work within the current context, which means trying to fit our demonstrations and tests in a SAIL 2, which is limiting, of course, the size of our equipment, for example. It is also limiting ourselves towards the trajectories that we can fly and not fly. Sometimes we have to fly trajectories which do not make a perfect medical sense, but that's what we are right now limited to. Basically, and so we are not always using the most efficient routes and not always the routes that are really making a lot of medical sense. And there is a lot of planning overhead into play basically with that. So when I talk about that, we have benefit in certification of the machinery, for example. So we are able then to demonstrate in higher risk, let's say, context. We reduce the risk of losing medical missions. We can have more efficient flight trajectories. And the downside, as I already mentioned, is indeed, and I think, and I already see a lot of hard effort, hard work going into that, making those certification requirements as efficient as possible. We are in demand, of course, for very safe equipment, very safety-driven demands towards organizations and training, but of course, thinking out of the box, not necessarily looking at manned aviation, of course, but also looking at, with a new eye from the unmanned world perspective, also looking at efficiencies, how we can, by reaching an efficient way to reach the safety goal, how can we reduce the cost for our end customer, basically. Because everything we do, all the time we spend in making things safe is having a cost. So making that most efficient while preserving, of course, that safety is very, very important to us. And that was me.
Thank you, Geert. So medical operation is something that will be very important to start, also because we'll meet the expectation from the public and general acceptance on the drone operations. So let's see now standards. There is also a question on Slido that is attracting a lot of interest regarding standards. So the question is that there are several requirements today for which standards are missing. So they want to understand what is the status of the standards, and also how we'll deal with the situation until the standard will be fully in place. Maybe the second part I may answer then later. But then, Abinaya, let's see what are the status on the standard. So I remind that if you want to ask questions, you can do on Slido using hashtag 472991. Please.
Thank you, Natale. Thank you very much. So I'm here to talk about the standardization perspective and talk about standards in support of the specific category. So I work as a technical program manager at EUROCAE, and as Natale said, I do support the EUSCG in a secretariat function, and therefore I wanted to start with an introduction to EUROCAE. So we are an independent, non-profit standard developing organization, and we are dedicated to aviation standardization. We have a long-standing successful record with high quality and safety critical standards, and we were recognized by the World Trade Organization's Code of Good Conduct for our open, transparent, and consensus-based process. When I say consensus-based process, I mean that we have an open consultation or a public consultation process that allows any member of the community to comment on a draft standard without having to be a EUROCAE member. We have a governance and a team dedicated to serving our members and the global aviation community. We have over 50 working groups, and currently I'm here in the position of Working Group 105, which we will look at. We have over 400 members, meaning organizations, and over 4,500 global experts that are registered on our, on our system. There's a link there to the EUROCAE website if you're interested in more information. So I did talk about Working Group 105. That is the working group that addresses unmanned aircraft systems, and we're divided into 6 subgroups. So what this working group essentially does is develop standards for integrating all types of UAS into all classes of airspace. The first subgroup addresses detect and avoid. The second one addresses standards pertaining to command, communication, control, and security. The third one addresses U-space, or UTM, if you will. And the fourth one addresses design and airworthiness. The fifth one addresses enhanced RPAS automation. And the sixth one addresses SORA. You can imagine if the working group is split into so many subgroups, it means that there's several activities ongoing under each of them. And I will not go into details, but you can find that information as well on our website. There is a steering committee that monitors and is pretty much an oversight of all the activities that's carried out within the subgroups. And we also have invited organizations such as EASA, EDA, SJU, DAFIS, and USPA that attend these steering committee meetings. The role of standards with respect to regulations. I do have a flowchart that comes up in the next slides, and I'd like to focus on that there. But I think we are all aware that standards do play a very important role with respect to the regulation, and it is really proving to be important for applicants who wish to certify against any particular regulation. Yes. So the EUSCG, I've said that a few times, and it indicates the European UAS Standards Coordination Group. It is a joint coordination and advisory group, so that essentially is for standardization activities. It monitors standardization activities that stem from EASA regulations, as well as the European Commission. It provides a link to bridge European activities to those at the international level. We do not work in isolation, so it does link those from Europe to those across the Atlantic. Some of the EUSCG members, so the EUSCG consists of the European Commission, EASA, Eurocontrol, main standardization bodies, the EU industry, and UAS operators. Taking a look at some of the tasks that's performed by the EUSCG. So there's several tasks that's performed, but one of the most important things is that we have a deliverable that we produce, which is called as the European UAS Standardization Rolling Development Plan, that's a mouthful, or URDP in short. So some of the other tasks that we perform is that we're a forum where we can address any issues that come up. We are also responsible for facilitating work sharing among standard developing organizations, and we also are an advisory board to the European Commission and any other bodies as needed. We have a meeting schedule where we meet 3 to 4 times a year. The last meeting was held in March, and the next meeting will be held in June. So far, we've published 6 versions of the URDP, which lists all the standards that are available, and we aim to publish the next version in April, and it will be available on the link at this particular website. So I spoke about a flowchart. Well, this is what I was talking about. So we have the EUSCG there, and you can see that the EU strategy on UAS feeds into the EUSCG. There is a feedback loop that's maintained in this regard, and we do have 2 other bodies, the EASCG and the ECSCG, which address ATM and cybersecurity aspects. A coordination is maintained between all these standards coordination groups, and the EUSCG also feeds into international activities and otherwise. So let's go to the top portion. We see some standard developing organizations there. There is a process that's maintained, so we do provide input on behalf of the EUSCG, and we do receive input from these SDOs. So an SDO receives an input for a standard, for example, and it goes into their internal standard development process, where they do their standard developing process. It goes through an approval process, and the standard is published. Of course, this internal standard development process varies depending on the SDO. On the bottom, we have EASA and the European Commission. So there is the rulemaking process. And in coordination with the European Commission, it is adopted, and then we have a regulation. So we have standards and we have regulations. And in most situations, the appropriate standards are then recognized as an acceptable means of compliance for the regulation, and it helps applicants to prove that they are compliant. Moving on, so we have the AW drones, or the Airworthiness drones project, and the Horizon Europe project. So I wanted to touch on this and also show how it is relevant with the URDP. The AW drones project proposed and validated technical standards to comply with the existing regulations for drone operations. It supported the rulemaking process by defining rules, technical standards, and the procedures to enable drone operations in EU. So the AW drones is essentially a repository of technical standards and the best practices for the drone community. One of the inputs for the AW drones project was the URDP that came out as one of the deliverables of the EUSCG. The AW drones was not a full member of the EUSCG, but given the important work that they were performing, they were invited to every EUSCG meeting during the duration of the contract. Following the work that was done by the AW drones project, we have the Horizon Europe project UAS standards. It was a tender that was launched by EASA last year, and the contract is expected to be awarded in April 2022. What this project will do is technically assess the standards that were proposed by the AW drones project. So for a regulation, it was proposed that this standard could be an acceptable mean of compliance. And this project will take that a step further and technically assess it to see if that would indeed be the case. Look at the AW drone standards portal. So you can find a list of the standards that they a list of the standards on their portal, and you can filter it by domain, document type, and status. So whether it's published, in draft, or which standardization organization has developed it, what's the document number, and so on. There is a link that's available in the slide, but if you go on Google and type AW Drones Standards Portal, I'm pretty sure it should pop up. So moving on, we were talking about standards pertaining to the specific category. There's two standardization topics that I'd like to address here. One is the use space, and my next slide will address SORA. So under the use space standardization topics, we have several SDOs that are addressing these topics. So ASD-STAN, ASTM, EUROCAE, Eurocontrol, ISO, and SAE. Some of the topics that's being addressed include aeronautical data provision and exchange, remote ID and tracking, flight planning and authorization service for global awareness in ATM, UTM use space, traffic information, situation dissemination, exchange format and service, and requirements for UTM services and service providers. The AW Drones project did identify some gaps in the standards that would be required. An example could be communication. So that was one of the things that was identified by them for drone identification. Moving on, so the SORA standardization topics. With respect to SORA, we have ASTM and EUROCAE that addresses these topics. Some of the topics that's addressed include the UAS safety analysis for the specific category, the sale to application of SORA, the use of multi-GNSS for UAS, and automatic protection of the flight envelope from human errors for UAS. Again, off the top of my head, some of the gaps that were identified by the AW Drones project were those pertaining to multi-crew coordination and remote crew. Yes, and I think that's my last slide. So the idea here was basically to talk about how standards do play an important role and how we can support and how standardization developing bodies can support the regulation and the applicant throughout this. So thank you for having me here, and it's back to Natale.
So thank you, Abinaya. So we understand that we identified the list of standards that may be applicable to the different requirements. So they are published on the AW Drone portal. And now we are checking which of the standards then technically really will be recognized as a set of means of compliance by EASA. But in the meantime, we identified gaps. And so, Abinaya, I have a question for you regarding the resources that EUROCAE and the standardization body are using, because I know that you rely mostly on the resources from industry. Here, we have sometimes a different industry compared to what we used to have on the manned aviation. So maybe they are not aware on how they can contribute in supporting the development of this standard. So if you can explain how it will be possible.
Sure. As I pointed out earlier, so we have 50+ working groups. We have 4,500+ experts and 400+ organizations that contribute to our activities. The standard drafting of the standards, developing the standards, and so on is done by the industry, more or less for the industry. And how we do this is that we ask organizations that are interested in contributing to these activities to join EUROCAE as a member. And they are then able to draft these standards, contribute to the direction of the standards, and so on, after which we go through our internal approval processes before the standard is published.
Thank you. So I think the message is that we need to do this activity together. So we need to have your support. So please join EUROCAE or other standardization body in order to provide support on developing on the missing standard. So, and to answer to the question that we have on slide also, how to deal with the situation until standards are fully in place. At this moment, so as I told you, we have already the list of standards that may be used. In reality, standards are not essential to show compliance with the requirements. For sure, they will help a lot, and we are working hardly to develop them or to identify some acceptable standard. But each then applicant may propose their way to comply with the requirement. And you may be aware that EASA is developing some means of compliance that I think will be discussed also in the panel later, especially on some elements of SORA, those that are the most critical. So we are trying to address those elements that at this moment will be more important to enable the initial operation. So we have a number of questions on the Slido. So let's start from the first one. I see that there is someone on the recognition of SORA worldwide. So apparently, so they are asking how SORA will be used in the near future outside of EASA. And it currently looks like only Europe is actually using the drone operation. I don't know, Leonardo, you want to answer this one?
Yeah, it's not only EASA that is using the SORA methodology. There are also the Canadian authority. I know also the Australian authority. And other authorities maybe are not endorsing in full the JARUS, but they are using the concept of it. And we plan to, not as a member of JARUS, we plan to extend as much as possible this methodology in the world. And I think we are cooperating with other authorities in order to ensure that we can recognize mutually the activity that is done for the operation according to this methodology.
Yeah, and the EASA invested a lot on the development of SORA, so you may be aware that at the beginning EASA was leading JARUS activity, because the purpose was exactly this one. Try to develop something that could be recognized at international level, so with the support of all different authorities in the world, and then develop something that may help our industry to be able to operate also outside of Europe. So then for sure we were the first one to implement directly SORA, and we saw that the SORA at this moment provides a very interesting concept, but some details needs to be better explained, so some standard needs to be connected to the different requirements, so this is what today we are doing. But we can only do after we have the experience, so after we receive from you the feedback on what is needed, to find really what is the proportionate standards, because on the other side it would be too easy to ask all the time to have the super safe drone, the super skilled pilot, and the super structured organization. So for sure it will make the operation safe, but on the other side then will kill the market. So we need to have also this kind of feedback from you to identify how we can make sure the operations are safe, but the other side also economically feasible. So you have another question. MPA 2020 provide guidance about sparsely populated area and allow the route to be overpopulated area for a small percentage. Is still allowed? Most of the hospitals are at the border of the congested area. Should we assume that the complete route to be urban, even if the route is 98% sparsely populated? It's quite a detailed question. I don't know if we want to try to answer, or maybe...
This is the MPH 2021-09, I guess.
Yeah.
Yeah, okay. We have already published the decision on this.
Yeah.
So it's already in the decision, the final approach of EASA. So I think it is what...
Yeah, so the MPA then resulted in the decision that was published in January. And actually we decided to split the decision in two pieces because there were in the MPA some elements on how to amend SORA for design-related topics. And since we are still having some discussion with the Aviation Authority, National Aviation Authority, and we did not finalize the change to SORA, so we only publish in the decision the elements related to all topics except design. And then we are now finalizing the second part, and the design part and also the SORA part will be published hopefully in the next couple of months. So definitely the approach is that we need to identify what is the risk of the operation. So that different elements come into play. So also the time at which an area is exposed. So what is the percentage of flight will be one of the factors that will be considered when the operator can propose to the competent authority some mitigation means. No, there is the sort of M1 mitigation, showing that they are exposing the population at risk. for a limited time. Next questions. One of the biggest challenge for operators is to develop the operation manual based on the outcome of SORA. A PDRA relieves operators from performing SORA, but not from the burden to develop an operation manual. Is EASA going to change this or simplify the process? So still
this is correct, yes. Actually, PDRA is only to skip all the process, but at the end of the day, the documentation to be submitted to the authority in order to obtain an operational approval, operations approval is the same. And the operations manual, for the operational manual, we are working now on a new version of the Annex A of the SORA, which is also published in the documentation in the MCGM of EASA, in order to simplify it, to increase the information and to guide better the applicant in the preparation of the operations manual. Of course, the operations manual is somehow, let's say, the complexity of the operations manual is somehow proportionate to the complexity of the operations. So for a SAIL 1 or 2, we don't expect a huge document, but the details that are triggered by the OSOs should be there. Yeah, we are trying to support in the means that we are improving the Annex A. So we have this new version that is currently under consultation, and I would like to repeat my invitation to have a look on this and to submit your comment to JARUS, because we will review these comments and we will embody them in the MC of the EU drone regulation. But the burden is there. I mean,
yeah, we should also remind that the operation manual is a document that is for the benefit of the operator and of their personnel. So it's not a document that needs to be sent to EASA or to the competent authority to show compliance with the required regulation. Should be the documents that the personnel should use in order to understand how to make the operation safe, and the SORA, and especially the Annex A, should be used as a sort of checklist to make sure that all the elements are inside. So this means that depending on the level of sale of the operation, we may have some simple procedure. So maybe for a SAIL 1, we may have really a 3, 4, 5 pages document. For a SEAL 6, where then we need to have very detailed procedures, then maybe it can be quite, I don't say how many pages, but quite a bigger document. So the next question, to improve the harmonization and reduce burden both on the US operators and NEAs, could we expect a consolidated list of UAS that are approved to be in compliance with the technical requirements, at least for some also in Step 9, published by EASA outside the scope of design verification report? So maybe I can take this one. So we are going, we are going to publish the list of design verification report that has been issued by EASA. So this is something. This will be a topic that will be actually covered more in detail in the next session. But our aim is that on our website we are going to make a small changes to the page on specific category. We are going to list all those drones that has been verified by EASA. In this way, the operator that wants to conduct an operation, first they can check on our website. They can identify which one is the drone is already compliant with the either the Step 9 or mitigation, or maybe already show compliance with some SAIL 3, SAIL 4, tomorrow also SAIL 5 and SAIL 6 with the type certificate. And then in this way, the operator is not required anymore to show compliance or provide any kind of declaration for this kind of drones. They can just contact the manufacturer of the drone, purchase the drone, then need to conduct the SORA, the risk assessment, or the PDRA, showing the requirements for all, show compliance for all the non-design related requirements, and then they can apply for the authorization, and the design part will be just demonstrated through the design verification report. So this will be in the aim of also simplification. Next question. Right now, there are only 2 standard scenarios for specific category, and as EASA once said, there will be no new standard scenario until 2025. Can you imagine that one of the new standard scenario later on will cover operation with certified UAS, or is too challenging to be subject of STS? So maybe this one I may answer because it was something we discussed quite a lot during the development of the regulation. You know that standard scenario is a big simplification. Simplification because you can just declare instead of applying for an authorization. But on the other side, we need to make sure that the operation is safe, that the operator is conducting the operation in a way such that we don't need to immediately verify what are their procedures, how is conducting the operation. So we decide to keep the operation only for lower risk. So we only going to publish standard scenarios that are for those operations that are up to SAIL 2. And this is also what is written in the regulation because we have one of the requirements, I think is spec 020, that is identifying what are the kind of operation that can be allowed out to standard scenario. So at this moment we are not planning any additional standard scenario, so because we will wait for the experience to develop a new standard scenario, but they will only be for those operations up to SAIL 2, so where no certificate of drones is required. But on the other side, the design of the drone will be verified through the class mark. So you know that today already the standard scenario 5 and 6, we required to use drone with C5 or C6. So also in the future, when we will have another standard scenario, maybe the C5 and C6 drone may be still acceptable, or maybe we will develop another class mark. This will depend. But so we will stay with this kind of concept. Okay, next. Could the EASA collect all standards and publish links on drone dedicated website to facilitate application process for operators? So maybe also here want to answer regarding the standards.
We have today there is an agreement with AW Drone, which are basically they are listing all the standards that are existing or under evaluation. I think we can rely on them. As soon as this will be approved, then we can endorse. But for the time being, I would suggest to use this website of AW Drone.
Yeah, exactly. So this will be what we will do only. So when we are going to then recognize standards, we are trying to continue this agreement with AW Drone to have all the information listed there. But then on our website, through our AMC, we'll identify those standards that has been accepted by EASA as that means of compliance. But I think that AW Drone portal will be the most interesting for everybody. Okay, so another question. Is EASA looking at providing regulation alleviation when drones can be used for saving lives? I refer to the analog logic of support hams in manned aviation. What do you think? Something that EASA may consider?
I think today we don't have it, but it's something that which we can discuss. Depends on.
I think it's an interesting question. Depends also here on the public acceptance. What do you think, Geert? This is something that may be useful.
Well, indeed, I think that the case is because I think the safety component is very much driven also by public acceptance, etc. And what I see is that there is a high level of collaboration also from emergency services, etc., to actually support medical activities, which means that actually there is a big acceptance at all layers, making the missions already intrinsically safer because of that, because people are more willing to collaborate to make them safer. Also the emergency services, for example. So, and local authorities, for example, are very willing to collaborate, making those missions already much safer. So I think there is a driver towards that.
Indeed, I think something that we can explore. It's already existing even in the street. When we see an ambulance, they don't respect the regulation that are applicable to other cars.
Yeah.
So it's
Leonardo, we have to be also careful because I'm not sure if the mandate of EASA includes the rescue services, and and today it's under national regulation.
And just about that, actually in a project that we are currently working in, the SAFIRMED, a VLD2 project basically, we're also defining, because just to be frank, not all medical transport is urgent also. So we have classifications, priority classifications, and there you could also make a distinction between what is really urgent, for example, that AED. For example, in an oncological operation, a tissue that needs to be urgently transported. These kind of a medicine that needs to be urgently administered. Urgent things. We are even within that medical realm, we're making classifications. So I think we can make, we also in ambulances not always using the blue light and the sirens. So also there we're making a distinction.
We need to rethink maybe what is rescue.
Yeah.
Is it an AED?
Yes.
Is it a rescue operation or not? Yeah.
And we've created the basis for that to make that distinction, actually listening to the medical community, also making that classification.
Okay, so thank you. This is something that we should include in our discussion.
Yeah, at least to discuss.
Yeah.
I don't know whether it will be our remit or not now, but it's a good idea anyway.
Okay. Yeah, this is the kind of input that I think will be very useful for us. So a question for Abinaya. Are there any standards in place or planned regarding the automated destination approach and landing process, thinking on ground support equipment, precision, tracking, privacy, etc.?
I think that's a very wide scope. Of course, there are standards that's planned for remote pilot stations, for example. There are standards that we do in the scope of cybersecurity, privacy, that could, again, be transversal to and be applied within the UAS domain. One point I'd like to raise here is if the person who raised the question has a very has an idea in mind and he thinks it's a standard that could prove useful for the industry and the rest of the UAS community, he is very welcome to approach EUROCAE, give us his proposal, and we would be happy to take that on board and see where we can take that. Like I said, we are for the industry and we are made by the industry as well. So yeah, that's something that we can offer here.
Okay. So I hope that this request has been heard and we can have some resources, because we need to help all the standardization body to do their work and to develop standards, but can only do if industry will provide the support. There's a question for Geert. Do you think urgent medical missions alone can be viable economic business case, or will non-urgent deliveries need to be incorporated? And what would that mean in terms of social acceptance and airspace management?
Mm-hmm. Very interesting question indeed. Well, of course, as I mentioned, for example, also in our case, our roots are in the medical case. So that's where we're starting from, that's where we're taking our requirements from. But nothing prevents from also using that same knowledge, using that same procedures and technology for also other use cases. And those could be less urgent cargo, those could be, let's say, other interventions from an inspection point of view that can be integrated. And I think adding those use cases to the same network of infrastructure can also benefit the medical community by increasing the volume of your operations, and as such driving the cost. You are actually spreading the cost of your infrastructure and your systems over a much bigger, let's say, use case, groups of use cases, which is actually driving also the cost down for your medical partners, because the drone is not just used for them, but also potentially for others. And then it's just a matter of having the right service levels with them, so that we can fulfill their urgent requirements, while also fulfilling other use cases. So I think yes, and it can even benefit the medical use case by driving down the cost.
Thank you. I see also another interesting question on SORA and the USpace. Will SORA be used for the risk assessment service in USpace, and how is positioned regarding USpace? So there will be a USpace session also today, so there may be some additional information can be provided there. But so in general, so the USpace is one of the mitigation measures for the air risk that can be used in SORA. So the risk assessment service, the risk assessment that is required for the USSP service provider, it may be something different. So and this will be better defined in the MCAGM that were published for consultation on USpace a couple of months ago, and were for consultation until a couple of weeks ago. And this will be better discussed in the next webinar. But here, so the USpace will be used by you as operator to mitigate the air risk. So this is the most powerful, the best thing to use USpace for us in SORA. So this will be the connection between SORA and the USpace. I have a question for Jeremie regarding the an evaluation of the community that we have here. So at this moment, we are having a community that is new in the aviation world, and especially in the continuing airworthiness, we are relying a lot of safety management on the fact that we have gained decades of experience. So how do you think we can help the community to speed up on this activity and understand what are the basic elements of safety management that anyway will be useful, even if we are going to ask them progressively with the level of risk?
Well, I think we will learn by doing. I think the first operation will not be in the 5 and 6. I think the other 3 already provide you a good way and to learn and to apply, to develop some procedures. So, and the community will learn by doing. In our role, in our proposal, we don't have a strict safety management requirements included, but we have compliance monitoring, we have other tools. And of course, when we get there to the 5 and 6 operation, and we will have to communicate and to explain what we do, what the expectations. So yeah, we will get there somehow, I think.
Thank you. So there is another question on the EW drone project. So compliment on the job drone project, thank you. I will tell them to the consortium. Could you explain the approach on allocation of resources to recognize already existing industry standards and discuss possible amendment, if needed, versus developing new means of compliance by EASA? So, allocation of resources, I think that Abinaya already explained what will be the future project, the future project that EASA already is carrying out. So there will be a contract that will be awarded in the next weeks, where we are going to have a consortium that will help EASA to now assess the technical content of the standard, because now we know which standard potentially being identified as means of compliance, but what is missing out to identify if the level of safety that they provide is really enough or not. We have a shortage of resources in EASA to do it, and so we have this contract, and this will be the next way in which we are going to allocate the resources, doing by that one. So in the meantime, with the means of compliance that we are publishing, we are already taking some elements from some standards that we know that are under development. And so we are extracting from those standards, even if they are not ready yet, something that is already mature. This example of the means of compliance on the flight termination system that was published in December as for consultation, and now we will have the final publication, hopefully in the next couple of weeks, where we took some piece of the standard from ISD STAN, and then we introduce in our means of compliance, and this will enable the applicant to declare compliance, in this case with the flight termination system for the step 9, without asking for design verification reporting, for example. But it's something that will be discussed better in the next panel. That will start, I think, at 11:15. So I think that we reached the end of our slot. I hope that this was interesting. So thank you very much for our guest, and so we wish you a good continuation of the day, and continue to follow the activity of EASA on our website. Yeah.